right, welcome back to another episode of Sake and Cyber. I'm here with a very special guest, Berg Severens. I was practicing your name, so hopefully I got it right.
Great, yeah.
We're going to be talking a little bit about kind of AI, its role in security. You have an interesting background because you're more from an AI engineering point of view and history rather than security, and now working in security. But maybe we can start with telling us a little bit about your background. But before we forget, I almost forgot the most important thing and reason why we all come here. We're going to try some sake today. So the sakes that we have in store is, our first sake is going to be from the Nara region in Japan again. And this time, this is from a specific region that is famous for soft water. So it should be fairly soft. The second sake that we're going to be trying today is from Hiroshima. And this is kind of famous for its Jinjo brewing technique. So we'll be a little bit sharper and a little bit different. So let's try our first sake. Cheers.
Mm.
All right.
Yeah,
all right.
It's actually sweeter than I remembered.
Well, let's start off talking about your background. So you've got an interesting background, but kind of at what point did you start becoming interested in AI, and kind of what's your history with LLMs, artificial intelligent neural networks?
So basically, I'm former founder of two different startups. One was in software for metal 3D printing, which got acquired by Octon. And there were 3 AI engineers on the team, and this started an important spark of interest in AI. And so I decided to start a second startup, which was called MON. This is an anagram of human, because we wanted to develop human-level intelligence. And so this was still in the more early days of OpenAI. And so OpenAI was like almost a direct competitor. But we developed like new kinds of neural network architectures, basically trying to compete with the transformer. The transformer is now the working horse of all LLMs. And we tried to challenge that statement. That's how I rolled into the AI world. Actually, before ChatGPT was released, and before like the huge boom of how AI is used today.
That's super interesting. So I'm curious, like for people like me, the role of the transformer. Can you dive into that a little bit of like how that works in these models that maybe we're using today?
Yeah. So maybe let's take one step back before the transformer. It's like neural networks in general. Neural networks in general are some kind of simulation of the human brain, and this simulation is like very basic. And the way how neurons are connected in our brain is still very different from how it works in neural networks, but at least we're trying to mimic those networks. The transformer is basically one way of connecting these neurons that show to be very efficient. And the great deal about transformers is that they are very scalable. So if you make those networks really, really big, the accuracy is getting better and better and better. And that was not the case for all neural network architectures that were developed prior to the transformer. So the key component of the transformer is scalability.
You've had a pretty wide kind of background in AI before AI was kind of cool, let's say, before everyone was using it. When did you start to look at the implications in security for AI specifically?
Well, actually, like almost a year ago, and at that time I was looking like what would be the next challenge for me, and I was always intrigued by the companies that Willem started. I know Willem for something like 10 years now, I think. And so I reached out to Willem, and we immediately discussed, okay, there is a huge opportunity for AI here at Aikido Security. And so we talked more about it, and was clear that there was a real match to join Aikido. And now I'm part of the auto triage team, and so basically we try to use AI to filter out false positives and also to give a better prioritization of the existing SAST issues.
So let's talk about triaging then. So let's just start off with, like, when we say auto triage or just triage in general in relation to security, kind of what are we talking about in this situation?
Yeah, so we're currently focusing on SAST issues. When we are talking about SAST issues, that means like there are vulnerable patterns used in source code. And so software files, these are then scanned, and we detect certain patterns. For instance, if, let's say, a join operation is being used for creating a file path, then there is a likelihood that there could be a path traversal vulnerability. But that's just a likelihood that there could be a path traversal issue, but that doesn't mean that it's a real one. And so this detection with hard-coded patterns, it creates a lot of false positives. And one of the main USPs of Aikido is to filter out false positives, to do real aggressive noise reduction. And that's really hard with hard-coded patterns. And LLMs have an opportunity to understand much more of the context of the code and to understand when something is a false positive and, yeah, to do a lot of noise reduction. It's just a tool in the toolbox. It's not just a tool. I think it's a bazooka in the toolbox.
I like it.
And I think auto triage alone reduces false positives with around 60%. And together then with all other tools in the toolbox, I think that the false positives reduction is around 85-90% or so for the SAST issues. So it's a bazooka in the toolbox.
So the auto triage really plays a massive role in kind of taking, let's say that you kind of capture all these results and then filtering out into like what's actually kind of let's say exploitable or reachable or these words. How does an AI model do that? Like what extra information is it providing? Is it analyzing? What is it doing behind the hood?
Yeah, so it starts with giving enough context to the model. And so typically we will construct a full call tree. So it's not just a vulnerable function, but also the callers of that function and the callers of the callers and so forth until you reach the endpoint. And so the next step is we will try to include all relevant libraries that are being used. So sometimes it depends on the used version of an ORM or a database or a schema validation library. And so we give all that context to an LLM, and then the LLM will try to rule out the possibility of an exploitability. And then that's always the first step. If it can really rule out all the different possibilities, for instance, there is this accurate sanitization or validation in place, then it can rule out that exploitability, and it will mark it as safe and ignore the issue. But then there is also the second step where the case is that if the LLM cannot really rule out the possibility of being exploitable, then it will also look at hints, like might something be user controlled? Like, is it probable or improbable? Or is this likely in a context where the severity would be high or not very high? Like there is a big difference in a login endpoint, or you're just managing the styles, the layout styles of a user. And so we will look at both severity and likelihood that something would exploit it. And so based on that, we will also do prioritization.
So in this kind of context, I guess what you could say is that the typical SAST, rule-based SAST, let's call it, it's kind of it's like a big net. It's capturing a lot of things. It's capturing some fish, but it's also capturing some junk in there. And the AI's role is to kind of like filter out that, so we're just getting with what we want, and it's doing that through various different methods. Is there then a risk of it getting it wrong in the sense of missing a true positive? Because the good thing about having these like rule-based kind of functions, that they may be noisy, they may have false positives, but you still could see everything. Now, I know the reality is different. I know that these systems just get ignored if they're too noisy. But to play devil's advocate, isn't there a risk that we then start trusting AI systems to really help us, and then something slips through?
Yes, definitely. It's definitely a risk. And the way we account for it is by building a huge benchmark of code samples. And so we run our samples against, we run our LLMs against that benchmark to check how many true positives would be filtered out. And what we see is that it's less than 2% that gets filtered out for the wrong reasons, and like more than it's around 60% of the false positive reduction that I mentioned earlier, which is the advantage. And so that's in fact a no-brainer that is acceptable, because at first it sounds like, oh, we're losing 2% true positives. But that's actually enabling the SaaS team to make much more aggressive rules. Which, with aggressive rules, I mean they can flag much more, and they can, a bigger net, and they can also find more true positives, which is bigger than the 2%, and so that helps to actually find more true positives because we can also filter out more of it.
It's a really interesting point, because when you said that, like, my brain immediately went to exactly what you said. It was like, oh, so we're missing out like 2% of the stuff. That sounds terrifying. But actually, I get what you're saying, is that because we can capture more things, we're actually capturing more information because we can be looser with the rules.
Yeah, and it's a misconception that deterministic rules are perfect. Like, deterministic rules also have been tuned to code samples, and there are ways to make them more aggressive. But it's always a trade-off between how many false positives would you allow and how many true positives do you care about.
Yeah. No, this is super interesting. I have some more questions, but let's move on to our second sake here. Okay, so we have here the sake from Hiroshima with the different brewing style. Now, I'm not going to lie. Last episode, we had two sakes. I could not tell them apart. So let's see if the palate has improved in 1 week. I think that's how it works, right? Cheers. No, very different.
Yeah.
Very different. It's stronger. It's not sharper. It's like stronger at the back, I feel.
Yeah, for some reason I have to think about the color of brown.
I know for sure. That's absolutely. Yeah. Not the most appealing color, but definitely, definitely that's what it's feeling. I feel like there's going to be like a sake person like watching this. It's just like dying on the inside that we're getting it all wrong. But that's all right. We're trying to learn. Yeah. Let's talk about the economics of AI economics. At the moment, there's crazy budgets, like insane things. We've seen the headlines that Meta is offering $8 trillion per week for someone to come do that. They're building like entire cities that are data centers. Is this going to be a case in every scenario where biggest budget wins? And how can you build these really important, finely tuned models, products without $8 trillion?
Yeah, it's a very big question for a lot of people currently. So currently there are indeed a few, maybe 3 top players like Anthropic, OpenAI, and Google, and then a bunch of followers like Meta, maybe also Mistral, DeepSeek.
If Zach's listening, he's squirming in his seat. That Meta is a follower.
Well, I'm not sure, but
it's all right. There's a very small chance that the Zach is in the episode.
Probably. I hope Jan Lequens isn't listening. They're head of AI. There are quite a lot of followers, and they are trying to challenge like the ones on the front. It's also surprising, like what something like someone like DeepSeek could do. They could surprise everyone suddenly with a lower budget than was expected.
Much lower, like by a factor of about 100.
Yeah, well, debatable because they had probably much more GPUs available than was known first. And it was only like the last stage of training before all the R&D that was published, like, oh, we spent only this amount of money on the final training after doing so many experiments that also cost a lot of money. Okay. But it's still surprising that a relatively small lab compared to Anthropic and OpenAI and Google was able to come up with that kind of results. So also a very important player to mention here is NVIDIA, because I think still 98% of the published papers in AI use GPUs provided by NVIDIA. It's still not really challenged as a company. But also, apart from the competition landscape, I think it's also interesting to mention Moore's law in this context for AI. I don't know if you ever heard about it.
I'm not familiar, but let's dive into it.
So Moore's law has been posted like decades ago, where a man named Moore said that the number of transistors on a chip is doubling every 2 years. And this law has been a fact like for the last few decades. And this is actually what enabled the development of AI. That compute has become much cheaper compared to several decades ago. And it's still continuing. And that's a very important factor in the economics of AI. So if you follow that law, and let's maybe try to formulate it a little bit different. Like, the price of compute is being cut down by half every 2 years. That's something that's still going on. And so if you take that law and you would calculate, like, what would it have it cost to ask one question to a ChatGPT if ChatGPT was developed in, let's say, 1956, which was the start of AI, then one prompt would have cost around 1 billion euros instead of like 1 cent. So that's the power of power laws, that if something grows exponentially, this is the big difference. But if you take this law of Moore, then you can imagine that in a few years from now, or a decade from now, like the economics around AI will also be completely different again compared to what they are now, because it will be again much cheaper than what we're seeing now. The question is also, will we get the same level of intelligence at a much lower price, or will we see a much higher level of intelligence for the same price as what we are paying now? And this will also affect the cybersecurity community a lot, the answer on that question. And probably it's somewhere in between. I'm not sure if the intelligence will keep on increasing and increasing at the rate that we're seeing, but at least it will certainly become more intelligent than what it is today. It's just not obvious how much more intelligent, and it will also get cheaper to what it is today.
5-10 years in the future, where are we in security as it pertains to LLMs? Do we have any traditional scanning, as in rule-based scanning, anymore? Is everything AI? And I guess if that's the case, like how do vendors, how do products differentiate themselves? Easy question.
Wow. Yeah, well, it's interesting because the economics will play a big role in it, not just the accuracy. Like one big reason that we don't do detection with LLMs today is because LLMs are quite expensive to do just detection, while you can use hard-coded patterns. Yeah. There are other obvious reasons as well, like also the accuracy is actually still better with hard-coded patterns to detect them. If you read like the academic papers on the topic, but yeah, it's a very difficult question to answer right now. Like there are so many different ways that the scientific community could go in. So I think also something that I'm waiting for is like a certain development in LLMs that's still not there, that surprises me. And this development is the ability of being able to learn from what it's doing. So we as a human, we have learned a lot during our education. Then we come in the working field, and then we learn by doing how we should adapt our knowledge that we learned in education to a certain niche. And then during working, we also think again and again about the things we are doing. And for AI, there is like a similar thing that they are just first pre-trained on a lot of knowledge. Then they are fine-tuned, but the fine-tuning is also very, very general for like any number of people. And then there is like the inference time where they do reasoning, and they reason about their own thoughts. And so there is like a big similarity between how we humans think and how AI thinks. But a very big difference is that we humans, we learn from what we do in the niche we're doing. And
I'm kind of thinking about this in the way at like if I went to school and university and then I came out at the other end, but I'd learned nothing else from that point on. Like that is my knowledge, right? And then
and you would actually work at a company, but you would forget everything you do every day again. That's like the state of AI today.
Okay, that's really that's very interesting. Yeah, that's very interesting. So it doesn't continue to evolve like we do.
People would probably challenge my point by saying like there exist fine-tuning methods, but these fine-tuning methods, what they basically do is they take a pre-trained LLM, and then they fine-tune on a number of example answers, and then it learns how to respond in a similar way. But it has very big disadvantages. Like, for instance, one idea could be like, let's train it on Slack. Then we have all the informal knowledge that's present on Slack, and we have like a huge knowledge base of what's going on in the company. But what comes out of it is that it's if you ask something like, can you give me a summary of the financial report of last year, then it will respond like, okay, I will work on it tomorrow.
I love it.
So the problem with today's fine-tuning methods is it learns how to answer, but not what to answer. So building up knowledge is something very different from learning how to answer.
We've almost come to the end, but we're going to finish off with a little bit of a game. We need some more sake for this game. The game is called Would You Rather, and I'm going to ask you two options. You have to pick one. Would you rather never use AI in a response, or only use AI in response? So every time someone messages you on Slack, every LinkedIn post, every email, either entirely written by AI or never written by AI.
If it was today, never.
Never. But in the future, there may be just maybe a complete AI Berg.
maybe.
I'll work on this tomorrow.
Yeah, sounds good.
Okay. In application security, would you rather only scan using an AI model to detect vulnerabilities, or only rule-based detection?
Ouch, that's a painful one. If it was today, I would still go without AI.
Without AI? Okay. AI is taking an L in this one here.
Well, the problem with AI is, like, if you only trust AI, then I'm also assuming that it's just incredibly hard to trust it everywhere, and then it will miss a lot of stuff. So a lot of the work we do is also like finding those niches where it really shines. So I wouldn't trust it today to do it everything.
Okay, I have one more. You can probably guess what it is. It's AI based again. Very similar. Would you rather only use AI generated code, or never use any AI generated code? Okay, but I'll add some stipulations. You're allowed to continually prompt. So you're allowed to, like, it can produce something. You're allowed to change it with a prompt, but you just cannot do the code yourself.
And can I still ask questions to an AI?
You can ask. So imagine, let's just say that you don't know how to code, right? And you're using Cursor. This is a scenario. Would you rather that or be the legendary engineer that is Berg?
Let's go for being the legendary engineer myself.
I thought AI was going to win this one for sure. I was like, all right, AI took a big L in this one. But Berg, thanks so much for joining me. I had lots of fun. Super interesting chat. And I hope to have you back on the show in the future.
Thanks for having me.
And we've come to the end of the episode. If you liked this episode, please make sure to subscribe to the channel, like the video. It actually helps way more than you realize. We're fairly new, but we're trying to bring great high quality content. So we would appreciate if you helped us out there. I'll see you all next week. And remember, stay safe.